Now see here we have done periodic motion and oscillatory motion. See here, all oscillatory motions are periodic, but all periodic motions are not oscillatory. This is one important line about the periodic and oscillatory motion. Now see here, in this one is that is the next one, that is called harmonic oscillation. So see here, the oscillation which can be represented or which can be expressed in terms of the function of sine and cosine. See, if any oscillation is represented or expressed in terms of the function of sine and cosine, then it is called harmonic oscillation. Now see here, because these two trigonometric ratios are periodic, they repeats their values after 360-degree angle. So after this harmonic oscillation, there is also simple harmonic oscillation. But see, in harmonic oscillation what happens actually, suppose you have taken this is the mean position of the particle, that is O, and this particle is oscillating along this axis, this line, suppose this is x and x dash, and this is the position O. This particle or this body is displaced to this point by a small displacement y. So when the body is displaced to this side, one force acts towards mean position, that is called restoring force. Because of this restoring force, body comes back to the mean position and goes to other side. Then again it comes back to the mean position, and this force is directly proportional to the displacement, but the displacement and force are in opposite to each other. So this type of the motion is called harmonic motion. And if a harmonic motion has got a constant amplitude and a single frequency, then this type of motion is known as simple harmonic motion or simple harmonic oscillation. So mathematically we can represent simple harmonic oscillations like this: y is equal to a sin omega t, or y is equal to a cos omega t, where t is at any time, y is displacement at any time t, and a is amplitude, that is the maximum displacement from the mean position to the either side of the mean position, and omega is called here angular frequency. So now simple harmonic oscillation can be represented by y equal to a sin omega t and y is equal to a cos omega t. So now let us see the graph for this one, first one for the sine function and for the cos function.